For our first quiz for Math 95. Basic idea here is we're dealing with these rational expressions, this guy and this guy, and asked to do something with them. In this case, we're adding them together. I think down here we're subtracting two of them. And then make sure you simplify your answer at the end. Okay, well the way you add these rational expressions, the way I think about it anyways, is think about it kind of like it's fractions. If this were 2/3 plus 4/3, what you would do is you'd add up the 2 and the 4. You add up the numerators and leave the denominator alone. The same idea here. I'm going to take the numerators, 3x squared plus 7 and x squared minus 16, and add those two guys together. And that whole thing will be divided by my denominator, which is 6x squared minus 5x minus 6. But my numerator up here, I have some like terms. I got 3 of these x squared things, and I got 1 more of these x squared things. So in total, I have 4 of these x squared things. And I got a 7 and I got a negative 16. So positive 7 minus 16, let's see, that nets out to minus 9. If you were at 7 on the number line and you move to the left 16 spots, you'd cross 0 and get all the way down to negative 9. And then on the bottom, 6x squared minus 5x minus 6. This is the answer, I mean, in a sense. The problem with this is it's not simplified. And it does say to simplify. Really, most of the work comes in simplifying. To simplify, well, if it were a fraction, if you had 8/6 and you wanted to simplify that, you might know that that simplifies to 4/3, but it's really because 8 is 4 times 2 and 6 is 3 times 2, and you cancel out those 2's. What I'm getting at is you can simplify fractions if you write the numerator and the denominator as products, as something times something. Same thing we're going to do here. The way you write this as a product instead of as a sum, right now it's 4x squared plus negative 9. It's a sum of two things. We want it as something times something. The way you write this as a product is you factor. Factoring, it's hard. I mean, there's a lot of different ways to factor. We went over these, some of them in class, but really it was a topic from a previous math class. Up here, 4x squared minus 9. I have 2 terms. The only way we can factor 2 terms in this class is by looking for a greatest common factor. In this case, greatest common factor is just 1. There's nothing in common between 4x squared and 9. Or by recognizing a special form, which I think I said 99% of the time will be a difference of squares. Here it's a difference of squares. 4x squared is a perfect square. It's 2x times 2x. 9 is a perfect square. It's 3 times 3. And anytime you have a difference of perfect squares like we have here, it'll always factor into what are called conjugate pairs, meaning 2x plus 3 and 2x minus 3. The numerator factors like this. The denominator, a bit more work to factor that one. So much work that I'm going to do it off to the side. Down here, I'm going to try to factor 6x squared minus 5x minus 6. There's a couple different ways to do this. There's this guess and check method where you kind of just jump straight to the final answer over here. I'm not going to do that. I'm going to do this 4-step process. First step in this 4-step process is to find 2 numbers that add to the coefficient on your linear term, in other words, negative 5, and multiply to the product of your leading coefficient and your constant term. All I'm saying is this 6 times this negative 6. 6 times negative 6 is negative 36. I want to find 2 numbers that add to negative 5 and multiply to negative 36. That's not easy. What I'm going to do is I'm going to list everything that multiplies to 36, or at least all the positive integers that multiply to 36. And this is a complete list. And then once you have this complete list, you can be like, well, I want it to multiply to negative 36. To multiply to negative 36, I'll have to have one of these negative and one of them positive. Negative 36 and positive 1, sure, that multiplies to negative 36, but it's not going to add to negative 5. To get them to add to negative 5, I'll have to select this pair right here, and I'll have to make this one the 9 negative. Right, the 2 numbers that do this are negative 9 and positive 4. Step 2 is to use those two numbers. Really, you're going to replacing. How about just replace? Replace negative 5x with positive 4x minus 9x. Note that positive 4x minus 9x really is negative 5x. It's the same thing. But I'm going to rewrite this differently. Instead of writing 6x squared minus 5x minus 6, I'm going to write 6x squared plus 4x minus 9x minus 6. Why would I want to do that? Because now I have 4 terms. I have a method for factoring when I have 4 terms. It's called factor by grouping. I don't really know where I'm going to do this. I'm a little short on room. Maybe I'll stick this over here. I take 6x squared plus 4x, and I think about that as a group. And then negative 9x minus 6, I think about that as a group. The greatest common factor in this first group is 2x, and if I factor out a 2x from these first 2 terms, I'm left with 3x plus 2. What my goal then becomes is to factor something out from these next 2 terms so that I'm left with 3x plus 2. Negative 3 is that thing that I would have to factor out to be left with 3x plus 2. What I now have are 2 terms, and they both have a 3x plus 2 in them. So I can factor out that 3x plus 2. Now this is gone, and this is gone. So all that remains is the 2x minus 3. All that work just to figure out what I write up here. I write 3x plus 2, 2x minus 3. Oh look, this thing right here, which was the correct answer, just the non-simplified version of it, can be written like this. This is better because now I can cancel out these guys. They both have a 2x minus 3. So what I end up with is 2x plus 3 divided by 3x plus 2. This right here is my final answer. Pretty hard problem. And you're still not done because now we got to do another one. Okay. Similar, right? Up here, I was adding together 2 rational expressions. Down here, I'm subtracting 2 rational expressions. The way you deal with it is pretty similar. You start by just, up there we started by adding the numerators. Down here, we're going to start by just subtracting the numerators. So I got 2x squared plus 2x minus 2. And from that, I want to subtract x squared plus 3x plus 4. Note the parentheses. The parentheses are important. I want to subtract all this stuff, not just the first term. That's my numerator. My denominator is x squared minus 5x plus 6. I have a common denominator here, so I can subtract the numerators. How many steps should I show? I guess what you would want to do now is combine like terms. But you can't combine like terms because of these parentheses. You get rid of these parentheses if you take this negative, or the negative 1 that's kind of implied here, and distribute it through the parentheses. If you did that, you might not have to write this step, but I'm going to write it just to try to make these solutions as complete as possible. If this negative goes through and hits each of these 3 terms, I'd get negative x squared, negative 3x, and negative 4. Still got this same denominator hanging out here, waiting to be factored. Note that up top here, I have a lot of like terms. I got 2 of these x squared things, and I got negative 1 of these x squared things. That nets out to just positive 1 of these x squared things. I have 2 of these x's, and I'm taking away 3 of these x's. You're at 2 on the number line, you move to the left 3 spaces, you're now at negative 1 on the number line. I have negative 1 of these x's. I'm at negative 2 on the number line, and I move 4 spots to the left. So I go to negative 3, negative 4, negative 5, all the way over to negative 6. What I'm saying is negative 2 minus 4 is negative 6. Leave the denominator alone. This is the correct answer, kind of. It's just not simplified. To simplify it, we're going to have to factor. This thing right here is a lot like this thing right here. It's right, it's just not done. Got to factor it. Fortunately, this one will be a little bit easier to factor than the one above. The reason it's easier is I have quadratic trinomials in both the numerator and the denominator. However, those quadratic trinomials have leading coefficients of 1. All right, I threw a lot of vocabulary at you there. Quadratic trinomial just means you have 3 terms, kind of like we did here, and the largest exponent is a 2. And you're like, yeah, that's what we had here, and that was not easy to factor. Right, because the leading coefficient, the number in front of the x squared, was a 6 here. It's not a 6 down here, it's a 1. There's a 1 here and a 1 here. It'll make it a lot easier. It's a one-step process to factor, unlike this three-step process up here. What you have to do for the top is find two numbers that multiply to -6 and add to -1. Well, let's see. What multiplies together to get me 6? 1 and 6 and 2 and 3. If I want it to be -6, it would have to be -1 and +6 or +1 and -6. Neither of those will add to -1. However, +2 and -3 will both add to -1 and multiply to -6. +2, -3. +2, -3. I've factored the numerator. If you're not good at factoring, multiply these two guys together. FOIL. You'll end up right back up here. Do that one more time. X squared minus 5x plus 6. Now I want two numbers that multiply to +6 and add to -5. Well, I already came up with a list of all the numbers that multiply to 6. It's not entirely true. These are all the positive numbers, positive whole numbers that multiply to 6. I could also get to +6 if this were -1 and -6. Yeah, but that's not going to add to -5. Okay, what about -2 and -3? -2 times -3 is +6. -2 plus -3 is -5. -2 and -3 is how I factor x squared minus 5x plus 6. Oh, look, I got the same thing on the top and the bottom. I can cancel those out. I'm left with x plus 2 over x minus 2, the final answer, and the end of this quiz. I guess that's that. I guess I'll end the video here.